Hello everyone, myself Sharad Marathe. I am working as a physics educator at Xii International School. Today we are going to discuss about the nucleus, that is the chapter number 12 of class 12. Okay. So, first of all, what is nucleus? We are going to see the composition of nucleus. We are going to see what is the size of the nucleus. So, today's topics we are going to discuss, that is composition of nucleus, then we will see the size of the nucleus, then we will see about the elements of nucleus, elements of atom, we can say elements of atom, then we will see the mass of the nucleus, so today we are going to discuss about these four topics. So let's start with the first one, that is composition of nucleus. So in previous chapter we have discussed about Rutherford model of an atom. In that we have discussed that when alpha particle is bombarded on a gold foil, so suppose this is the alpha particle, this is its nucleus, okay, and the alpha particle is bombardment. We have seen the structure configuration of the experiment, okay. Now suppose, so what we have observed, that most of the alpha particles were passing through the gold foil, but few were there those who were returning back, few were there those who were returning back. From this, what Rutherford has said, that in the center of the atom, in the center of the atom there is something which is very heavy, and the whole mass of the atom is situated at the center. So from this, what he said, and that mass of the atom, we can say most mass of the atom is situated at the center, at the center. Then the second conclusion what he has done, that the center has a positive charge, the center has a positive charge. These are the observations of the Rutherford model. So from that what we come to know, that in the center there is a positive charge present, that we call that we called proton, that we called proton. So what scientists were doing, that okay, at the center of the nucleus, at the center of the nucleus a positive charge is there, and electron is revolving around it, and the electron is revolving around it. But when the mass spectrometer has measured the mass of this nucleus or atom, we can say about the nucleus only, it is said that the actual mass was less than the projected mass. Actual mass was less than the projected mass. So how that difference came, that we will see. So composition of nucleus, so there are proton and another particle was there, that is neutron, So neutron was found by J. Chadwick in 1932. In 1932, neutron was found by the James Chadwick. Okay, so nucleus has proton and neutron, and both these proton and neutron are called nucleons. Both these protons and neutrons are called nucleons. So if somebody will ask you that which particles are there in the nucleus, so you can say that nucleons are present. What are nucleons? Nucleons are proton and neutron. Nucleons are proton and neutron. So I hope that it is clear to you. So that nucleus is made up of proton and neutron. Okay. Now we will move on to the size of the nucleus. So size of the nucleus, if I will say you, suppose you have seen the 5 kilometer, you have seen the 5 kilometer radius ground. Okay, suppose the atom is of a radius 5 kilometer. Atom is a radius of 5 kilometer. Then its nucleus will be a size of a ball. Nucleus will be the size of the ball. So what we come to know here, the size of the nucleus is very small. That's why during the Rutherford experiment, most of the alpha particles will go through the gold foil and only few number of alpha particles were returning back. Okay, so come to this point, size of the nucleus. So it is observed that the size of the nucleus, the size of the atom is approximately 10 raised to minus 10 meter. This is the size of the atom. This is the size of the atom, and the size of the nucleus is approximately 10,000 times small than the size of the atom. So the size of the nucleus is approximately 10 raised to 14 meter. That is size of the nucleus. That is the size of the nucleus. So, and this we can write down 10 raised to minus 15 meter also. Okay, we can write down the size of the nucleus is 10 raised to minus 15 meter. So, what about the size of the nucleus? That size of the nucleus is approximately 10 raised to minus 15 meter. Now, we will discuss about the elements of atom or nucleus. Okay, that will say the elements of atom or nucleus. So, in this, first of all will come atomic number. First will come atomic number. Then we will see mass number. Okay, so these two are there. So if we want to write down the configuration or composition of atom, okay, always we are writing in this manner. Suppose X is any element. Here we are writing the Z, that is atomic number, and on top of that we are writing the mass number. So this Z is called atomic number, this A is called mass number, this Z is called atomic number, A is called mass number, and you will be very surprised when you will come to know this atomic number is nothing but it is the number of protons. It is the number of protons, and this mass number is nothing but it is the number of protons plus neutron. Okay, mass number is what? Number of protons plus number of neutron. So first of all we will see about atomic number. What is atomic number? Atomic number is nothing but it is the number of protons. Number of protons. Why only number of protons? Can we write down the number of electrons? Yes, because atom is electrically neutral. Atom is electrically neutral. So we can say that the number of electrons are equal to number of protons. The number of electrons are equal to number of protons. That's why we can write down atomic number as number of protons, or we can write down number of electrons also. Okay. Now mass number. What is mass number? That is number of protons plus number of neutron. What is mass number? That is number of protons plus number of neutrons. Okay. So if I'll ask you that 1H2. If I will write down in this manner 1H2. So what is 1? 1 is the atomic number. 1 is atomic number and 2 is its mass number. We can write down it is as a atomic mass also. Atomic mass number, atomic mass or mass number, whatever you want to say, you can say. So I hope we have cleared the composition of nucleus. Then we come to know about the size of the nucleus. Then the elements of the atom or nucleus. In this also we are going to see few things. The first one is isotope. Then second will come isobar. Third will come isotones. Isotope, isobar and isotones. So let's see what is isotope first of all. So if I will write down here, you have to see 1H. Here I will write down 1H1, 1H2, 1H3. What are the things common here? What things are common here? So you can see that 1, 1, 1. Their atomic number is same. So we can say the isotopes are the elements or who have the same atomic number. Those who have the same atomic number. But you can see the mass number is different. So isotopes are what? Same proton number but different mass number. Atomic number is same but atomic mass is different. So we can write down that atomic number is same but mass number is different. What about isobar? So isobar, in the isobar we can say that mass number is same but atomic number is different. Example, I'll write down 6C13, let's write down 14, 6C14 and 7 and 14. You can see here the mass number is same but atomic number is different. You can see here the mass number is same but atomic number is different. So these are called isobars. So isobars, what is the meaning of isobar? That isobars are the same mass number but different atomic number. Same mass number but different atomic number. I hope it is clear to you all that what is isotope? Isotope is the atomic number is same but mass number is different. But what about isobar? Mass number is same but atomic number is different. Okay. Now last one. What is that isoton? Isoton. Ton stands for neutron. We have to remember in this manner. Ton stands for neutron. Okay. Example, 6C13. Okay. Shall we write? Okay. 6C13 and boron 5B or 5B12. Okay, so these two are the examples. 6C13, 5B12, carbon 13, boron 12. See, now how we are finding the neutron number? If you want to find out the neutron number, you have to write down. If you want to find out the number of neutron is equal to mass number minus atomic number. So how we will find out the number of neutrons present into the nucleus? That the mass number minus atomic number. What is atomic number? Atomic number is nothing but it is the number of protons present into the nucleus. So Here we will see 13 minus 6, 7, 12 minus 5, 7. Both have the same number of neutrons, so that is called isotones. That are called isotones. Next time when we'll meet, we'll discuss about the mass of the nucleus. I hope whatever we have discussed that is very clear to all. We have discussed composition of nucleus. Nucleus is made up of neutron and proton. Then we have discussed about the size of the nucleus. The size of the nucleus is approximately 10 raised to minus 15 meter, or in other words you can say it is approximately 1 Fermi meter. Mass of the nucleus, that we will see in next lecture. Elements of the atom or nucleus. Elements, we have seen the atomic number, we have seen the mass number. What is atomic number? Atomic number is nothing but it is the number of protons. What is mass number? Mass number is nothing but it is a proton plus neutron. And along with that we have also seen the isotopes, isobars and isotones. What are isotopes? Isotopes is the where the number of proton, or we can say atomic number is same but their mass number is different. Isobar, yes, what? Isobar mass number is same but atomic number is different. And what about isotone? Their number of neutrons are same. Okay, so you just write down all the things in your notebook, and during the exam time it will be very helpful to you. Thank you.